All right, everybody. Mr. Moriarty here. So, what we are going to do today is I'm going to walk through the notes that you guys need to fill out today. I am recording this from my house, so there is quite a glare around this general area. I'm going to do my best to try to avoid that. I also forgot my calculator at the school, so I am going to be using Desmos on the computer. Okay, so I'm going to try to make this, I don't know, as good as possible. We did several of these problems in class on Monday. So if there's any problems that we have already had, just fast forward this video and then we'll go to the next problem that you need. But in order for you to get your assignment today, you need to make sure that you have your notes completed and you show the sub these notes. So I am going to run through this kind of more quickly than I would in class because it's kind of a go at your own pace situation. So here we go. So these steps, we discussed these steps in class. First thing that you need to do is you need to identify the variable. So figure out what is the missing piece in the problem. Then you need to write an equation, and then you need to solve the equation. All right, so those are the three steps right there. That glare is really bugging me. That's okay. So this was the first problem. Most people have this. I'm going to walk through it, though, just in case. So it says the school has budgeted $2,000 for an end-of-year party at the local park. The cost to rent the park shelter is $150. How much can the student council spend per student on food if each of the 225 students receives a $3.50 gift? So what we are missing here is we are missing essentially the cost of food per student. So the variable that I used in class is F. You can use whatever you want as long as you tell me what it means. So I'm going to say cost of food per student. Okay, cost of food per student. The equation that I had you guys do was, remember, we kind of set it up in terms of words before numbers, just to get an idea of the structure of the equation, since these are multi-steps on the front side. So we had a total, and what made up that total in this problem? We had the park shelter. So we had the park shelter, and then in addition to that, we had the student costs. So let me zoom out here. So we know that each student is going to get some food, and each student is going to receive a $3.50 gift. So what I did was I took the number of students and then we're going to distribute the food plus the gift. That was pretty much how our equation was set up. So then we can throw our numbers in there. We had a total of $2,000 to spend. The park shelter was $150. There were 225 students times the food, which we don't know, so the cost of food per student. So we'll use that variable F. And then the gift is $3.50. So this is our equation that we are going to use when we solve. So I'm going to bring this over here, and then we're going to go ahead and solve it as we would a normal equation. So I'm going to start by kind of divvying up my sides here, left side, right side. Our first step is always going to be look for distribution. I'm trying to get that glare out of the way. Look for distribution. So that would be between the 225 and then everything in the parentheses. So I'm going to bring down 2,000. 150 comes down, and then we distribute 225 times F. That's easy enough. That's 225. 225F. This is where I'm going to use Desmos. 225 times, this is the distribution that I'm doing, 225 times 3.50, and it looks like it gives me 787.5. Okay. Next step is always combine like terms. So the like terms that I have are 150 plus the 787.5. So again, I will bring down my 2,000. So 787.5 plus 150 gets me, nope, 787.5 plus 150. There we go. It's going to be 937.5. So that's after I combine the like terms, plus the 225F. Next step is to get your constants on one side. So I'm going to subtract the 937.5 on both sides. Take 2,000 in Desmos minus the 937.5. Gets me 1,000. This will cancel. 1,062.5 equals just that 225F. Your last step then is to, is to divide both sides by 225. That gets you, I remember from class today, I believe it's 4.72 repeating equals F. I'm just going to make sure I do that correctly in Desmos to make sure I mess anything up. 1062.5 divided by 225. That gives me 4.72 repeating. That's right. So then what does that mean to the problem? Well, what that means is that each student or each student's lunch or each student's food, I don't know if it's lunch or not, but each student's food will cost $4.72. All right, that one was a little bumpy, even after doing it, 5 times today. So there we go. That's the first one. Next one. Some classes got to this, some did not. So if you did not, then you need to follow along with this. Easy Car Rental charges $40 a day plus 25 cents per mile. Ace Rent a Car charges $25 a day plus 45 cents per mile. What number of miles results in the same cost for one day? Trying to use my head to block that glare. What are we missing? We are missing what number of miles. So identify that variable. I'll use M. It's going to represent the miles. Then we need to write an equation, and this one is kind of a comparison of two. Let me move that down. Of two companies here. We've got the Easy Car Rental and the Ace Rent a Car. So what I'm going to use is, for our equation, setting it up, I'm going to do the Easy Car and set that equal to the Ace Car. And the reason I know to set it equal to each other is because we're looking for the same cost, which indicates we want them to be equal. So the Easy Car, we know, charges $40 per day plus 25 cents per mile, which we don't know how many miles we have, but it's 25 cents per mile. That's going to equal, Rent-A-Car charges $25 a day plus 45 cents per mile. Okay, so there is our equation right there. I'm going to go ahead and copy this over here because that's the equation we're going to use, and we're going to solve it. So I am going to start by subtracting 0.25 m on both sides. Not the only thing we can do, but it is going to result in a positive. You can't see that, sorry. It's going to result in a positive variable term. These will cancel. Be left with 0 equals 25 plus, I can do this mentally, 0.20 m. All right. Now it's a two-step equation, so I'm going to subtract 25 from both sides. 40 minus 25 is 15. These cancel. We're left with 0.20 m. And then your last step is to divide both sides by 0.20. I don't know what that is, so I'm going to use a calculator. So 15 divided by 0.20. Got it. So that's going to give me 75 equals m. Now what that means to the problem is that, and I'm just going to kind of do a short little sentence here, but I'm going to say the cost is what we're looking for to see what the same cost is. So use my head again here. The cost for both companies will be the same at 75 miles. Okay. Just like that. 2 down. All right. Next one. This one, I don't believe we did this at all in class. So this is going to be kind of brand new material on this one. At the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride ticket costs $1.50 less than a snack. I'm going to go ahead and mark this as a turnaround word just because I know that's what it is. If he spent a total of $24, what was the cost of each snack? So the variable we're looking for is what was the cost of each snack. So I'm going to go S on this one. Cost per snack. That's a K. Oh my gosh, terrible handwriting. There we go, cost per snack. All right, the equation. So this is one I kind of need to think about here because I'm not used to going through it like we did in class. So it says at the fair, Hunter bought 3 snacks and 10 ride tickets. Well, I know there's going to be a total. So I'm going to start with that. Total is going to equal something. Then the next part of this is going to be what makes up that total. So bought 3 snacks, 10 ride tickets. Each ride ticket costs $1.50 less than a snack. Okay. If I'm thinking about this, 3 snacks, 10 ride tickets. So I would think about this in terms of, I think this is going to be the snacks plus the ride tickets, right? Essentially, that's what we have, right? The snacks plus the ride tickets. Okay, so let's see if we can throw some numbers in here. So the total is $24. The snacks, he bought 3 of them. We're looking for the cost of each snack. So I'm going to say he bought 3 snacks. Okay, so 3 times, so that's the quantity of snacks that he bought times the price of each snack. So that's where I got my 3S from. The ride tickets, he bought 10. and each ride ticket costs $1.50 less than a snack. So what I'm going to say is so 100 or $1.50 less than a snack. Remember, that's a turnaround word. So I'm going to take the S, the snacks, minus the $1.50. Okay. That is at least how my brain processes this one. Since we didn't do it in class, I'm not really sure 100% if there's any other ways or not to do it, but this at least makes sense to me. So again, at the fair, he bought 3 snacks, so 3 times the price or the cost per snack, plus 10, because there's 10 ride tickets, and each ride ticket costs $1.50 less than a snack. That makes sense. That makes sense to me. Okay. So I'm going to go ahead and we will copy this, paste this, and go ahead and solve it. So I'm going to bring the 24 down because the first thing that we look for is distribution. So I'm going to distribute 10 times S, which is 10S, and then 10 times negative 1.5. I want to make sure I do this right. So 10 times negative 1.5. That is going to get me negative 15. So I'll just put minus 15. All right. So there's the distribution. Now we need to do the combining like terms, but your like terms on the right side are going to be the S's. So on the left side, bring down 24. 3 plus 10 is 13S. Bring down the minus 15. Okay. Should be a two-step equation at this point. So I'm going to add 15 to both sides. That gets me 2, 3, 4, and 5 is 9 equals 13S. And then I'm going to go ahead and divide both sides by 13. That gives me, 3. So 3 equals S. Okay, 3 equals S. And what that means to the problem with S being cost per snack, we'll just restate the question. So each snack costs $3. All right. And that's the front side. Okay, that is the front side. Let's go ahead and go to the back. So for the back, translate and solve two-step inequalities. Steps are still the same. We're going to identify the variable, write an inequality, and solve the inequality. And the last step that we had on these was interpret the solution. How does that relate to the problem? So we did the first one. I believe everybody did this one. So I'm going to go through this one pretty quickly. Halfway through the bowling league, Stewart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stewart to have at least 61 strikes, the league record. Interpret the solution. What are we looking for? That's our variable. We want how many more games. So I'm going to use the variable G for games. For the inequality, and these are all 2 steps, so this should be pretty straightforward, is I'm going to start with, just to help my inequality along, I'm going to start with what makes up the total, figure out the inequality sign, and then put the total back in. So the total is 61 strikes, which is going to be the total strikes that he wants. But what makes up that total is what he already has. So I'm going to say strikes already. Not great grammar, but it'll work. In addition to that, we know his rate. It's going to be 2 strikes per game. So I'm going to add just the strikes per game. In class, I drew this big circle here, and that is where we are going to put our inequality sign. And then total strikes is what we have there. Now, he wants to break this record. Okay, so Stewart has 34. To find how many more games it will take for Stewart to have at least is the key word here. If we want something that is at least, that means it's okay to get that amount, but at least means it's also okay to get more. So I'm going to use greater than or equal to. So his strikes that he already has, plus the strikes he averages per game, can be larger than or the same as total strikes. So that's what we'll do. He's got 34 strikes. He is adding his strikes per game, which is 2 strikes averaged per game. Throw in the inequality sign, and he's looking for 61. That is going to be our inequality that we are solving. So I'm going to set it up, solve it similarly to an equation, as long as there's anything or isn't anything that we need to do with this inequality sign. I'm going to start by subtracting 34. These will cancel. 2g is on the left, greater than or equal to. 61 minus 34 is 27. And then your last step here is to divide both sides by 2, which gets g is greater than or equal to 13.5. We discussed in class that since you can't have 13 and a half games, or at least I don't think you can, we're not pretending that you can in this, since you can't have 13.5 games, you need to round up, not just because of the 0.5 tells you to round up, but if we were to round down to 13 games, that's less than 13.5, which means he would not hit his 61 strike limit. So we're going to round up to 14. And then what that interpretation means is basically Stewart I'm going to say must bowl at least 14 games. There's probably a glare on that. Yeah, Stewart must bowl at least 14 games. It's okay if he bowls more because he's just going to get more strikes. But it has to be at least 14 games. And there's a lot of different ways to write this interpretation. This is just what makes sense in my head. So yeah, that's the first one. Some classes got to the second one on here. It was depending on the time. So we'll do this one. We're going to do them all. But yeah, we'll do this one. If you don't have it, write this down. So it says a rental car company charges $45 plus 20 cents per mile to rent a car. Mr. Moriarty does not want to spend more than $100 for his rental car. Write and solve an inequality to find how many miles he can drive and not spend more than $100. Interpret the solution. We are missing in this one. It says write and solve to find how many miles. So I'm going to go ahead and identify my variable as miles. In terms of the inequality, we just kind of know about the rental car company. And then we also kind of know our total, the number that we can't go over. So again, just like the previous one, I'm going to start from what makes up that total. So we've got the, I'm going to say, I guess, the company charge. And to that, we're going to write the charge per mile or the cost per mile. I'm going to go ahead and draw a big old circle so I can put my inequality sign in it, and this is going to be the total cost. All right, so you have to think about this problem. So Mr. Moriarty does not want to spend more than $100. So that means I could draw a rectangle. Okay, so what that means is that our cost cannot go over $100. It's okay to hit $100, but it cannot go over that. So the company charge and the cost per mile have to be less than or equal to the total cost. All right. So when we throw our numbers in there, the company charge is $45. The cost per mile is 20 cents per mile. Inequality sign less than or equal to $100. Okay. So I'm going to go ahead and copy this over to the solve portion. Make it a little bit smaller. And then we can solve it. So I'm going to start by subtracting 45 from both sides. These 45s will cancel. We'll be left with 0.20 m is less than or equal to 55. And then our last step here is to divide both sides by 0.20. All right. And I'm going to use a calculator on this, so we are going to take the 55 divided by 0.20. When you do that math, you're going to get m is less than or equal to 275. All right, so remember m being miles, m being miles here has to be less than or equal to 275. So the interpretation then of that would be, I'm going to say Mr. M can drive no more than 275 miles. Okay, so that is the second one. Like I said, a few classes got that. Not everybody got that, though. So if you don't have that, make sure you do have that. And then this last one is, I don't believe anybody got to. So we'll go ahead and check this out together. Tyler needs at least $499 for a new PS5. He has already saved $149.70. He earns $10.15 an hour at his job. Write and solve an inequality to find how many hours he will need to work to buy the PS5. Interpret the solution. What are we missing in this? Think about that for a second. If you want, pause the video, try this on your own, and then come back. So we want to find how many hours he will need to work. So I'm just going to use H. It's going to be the number of hours. All right. The inequality, set it up again from the perspective of what makes up the total on one side, and then on the other side essentially going to be the total cost. So he's already saved. So I'm going to say money saved. In addition to money saved, we will be adding the money earned per hour. Then we'll have our inequality sign. And then this is going to be I would say the total cost, because we're still trying to buy something. Right? Now think about this. He needs at least, so that tells you what your inequality sign should be. And that kind of makes sense. He needs at least this much money. Think about it. If he makes more money than that, he can buy himself a game. All right. So the money saved plus the money earned should be greater than or equal to the total cost. So that's how I'm going to set up this inequality. So he's saved $149.70. He earns $10.15 per hour. And that has to be greater than or equal to the cost of the PS5, which is $499. Right? Interpret the solution. We're not there yet. Sorry about that. Got a little ahead of myself. Copy, paste. I'm going to put that maybe down here just because it's kind of a long inequality. Solve it like normal though. Minus 149.70 minus 149.70. I will need to use a calculator on that. 10.15h is going to be greater than or equal to. So $499 minus $149.70. That's going to get me 349.3. Okay. That's what I got so far there. Second step, last step, divide both sides by the $10.15. Again, I'm going to use a calculator here. So the 349.3 divided by 10.15. Okay, so it's kind of a lengthy decimal. Since it's dealing with cost and price and all that jazz, I'm going to round it. So I've got 34.4137931. So I'm going to say, well, I'm definitely going to round it because think about what our H represents. H represents the number of hours. Typically, you're not going to be able to just work part of an hour. So I'm going to round it to the nearest hour. So let me write down what I got. If I just round this to something else, so 34.41, right? But we discussed this on one of the previous problems. I think it was the bowling problem. You can't have kind of a part of this, especially an hour. Especially if you guys have jobs, you can't just work part of an hour. So we are going to have to round this up. And the reason we're going to round this up is because if we round this down to 34, just 34 flat, that $34 is, or sorry, 34 hours is not enough because it's less than 34.41. So I'm going to round this to 35 because I know like it's a little bit extra. It's a little bit extra, but it's still more than 34, which 34 would be less than the 34.41. Got it? Cool. I feel like I described that way too long. So interpret the solution. H is greater than or equal to 35. If our H is hours, what's his name? Tyler. Tyler must work. I'm going to put at least 35 hours. Okay. There you have it. All right, that is the last problem on this. So once you finish this problem, make sure that you've got the rest of them completely finished. Go ahead and show the sub, and they will get you your assignment for today.